Okay, so welcome back. Where we left off our project, we had just created random pieces on the board, and we needed to start actually being able to move the pieces around, and later be able to detect matches, and when we have those matches, destroy the pieces. So today we're going to be talking about how we can move the pieces around. And to do this, I'm going to just explain some stuff here on a piece of paper. So essentially, the main idea that we have, just focus that, there we go. The main idea that we have is that we have our screen here, and when the user touches a specific dot, we're going to calculate that as like the first position of their touch, or where they're first touching the screen. So we'll call this first touch. And Unity considers a touch to be the same thing as a left mouse click for the most part. There's some differences with multi-touch, and it's better to actually use Unity's touch system, but for now we're just going to use left mouse clicks. Then the user's going to move their finger in a direction, either up, down, left, or right, and wherever they move it to, we're going to call that their final position, or final touch. Now, based on the angle in between these two places, we're going to either consider that a swipe up, a swipe down, a swipe left, or a swipe right. And we'll swap the position of this piece with the other piece depending on which direction it was. Now, to figure out the direction, we're going to have to use a little bit of trigonometry. Well, there's more than one way to do it, but I think it's best to use the trigonometry. So if you think about the way that we're creating this, if you swipe up, you're never going to swipe perfectly up. You're always going to swipe kind of at an angle. So let's imagine that we have this right triangle here that consists of our swipe. So we'll have an X difference here, and we'll have a Y difference here. And we want to figure out what the angle in between this spot and that spot is using the X difference and the Y difference. If you remember your trigonometry, according to this angle, this is opposite, this is adjacent, and so we're going to use the tangent function. So the tangent of the angle, which we'll call x here, normally we call it theta, is going to be equal to opposite over adjacent, so it's the y difference over the x difference. Now to solve for this angle, you use a function called the arctangent, or not necessarily inverse tangent. I hate calling it that because that's actually cotangent, but anyway, you use a function called the arctangent. And so if you do arctangent of y diff over x diff, y difference over x difference, what you get back out is that angle. And based on what that angle is, so if we imagine we've got this almost unit circle here, Unity calculates this slightly differently than a unit circle, but if the user swipes anywhere in here, we want that to be counted as an up swipe. And so we'll call this 45 degrees, and then this is 135 degrees. If they swipe anywhere in here, we want to count that as a right swipe. So 45, and this is actually considered negative 45 according to Unity. And then from here to here, which is negative 135, that's a down swipe. And then in between these two, that is a left swipe. Okay, so let's get to the code. Okay, so back in our Unity project here, if I hit the play button, you'll see kind of what we have left up from last time. And there's a few adjustments I want to make first. I think these dots are a bit too big, so I'm going to adjust their size a little bit. So if I go out of play mode, I'm going to go back to my art and my dot art. Right now I have it set so that each dot takes up exactly one Unity unit. I'm going to want the dots to take up a little bit less than that, just so that there's some visual space between them. So I'm going to change this from 512 to, let's say, if we add 128 to that, that would be 640. Let's apply that and then hit play again and see how that goes. Okay. So now if I hit play, dots are a little bit smaller. There's some space in between them. That's probably better, but I want to go a little smaller than that even. Let's do 768. I'm counting up by 128 because it's a factor of 512, which is what this is. So if I hit apply, we're going to see how they look now. Oh, yeah, I have to actually hit play. Jeez. Alright, that's way better. There's some space in between the dots. There's a little more visual interest. Now, what I'm going to do is I'm going to go to my scripts, and I need to change a couple things here really quickly. The way I set stuff up last time was not as good as I could have done. I don't know what I was thinking, quite honestly. So if we go to our background tile here, the script for this, I'm going to open this up in Visual Studio. You can use MonoDevelop if you want to. The way I have it set right now is I have the dots being created as children of the tiles, which is good for organization in our hierarchy, but let me show you the problem with doing it that way. So if I create the dots as children of the tiles that they're created from, then their position defaults to 0, 0, 0, whereas the tile that they're on actually has the correct X is the number of columns, so this is column 2, and this is row 5. But the dot that's created there doesn't have that information. So like this one thinks it's 0, 0, 0 because it's being created as a child of the tile. So I want to change that. So in my background tile script, I'm going to take out all of this integer.toUse, da da da. So I'm going to grab this and I'm going to cut it, and I'll go back over to the board class now. So in the board class, after I create my background tile, I'm going to create this dot as well. Now, the board class right now doesn't know anything about the dots array that we created, so I'm going to grab this array again. I'm going to cut this out because I don't need it to be in the background tile class. I'm going to add it right here where our other prefabs are. So now I know what the dots are. This is going to get created. I'm going to have its parent be the board this time instead of the background tile. And then I'm also going to have its name be, I'm going to name it the same way I named the background tile. So I'm going to grab, oops, I want the whole string. I'm going to grab this string here, copy it, and paste it right there. So I'm going to save my code, pop back to Unity, and make sure I didn't just break anything, and that things still operate the way they're supposed to. Oh wait, they're not going to operate the way they're supposed to. Okay, so yeah, so the reason they're not going to operate, if I hit play right now, all the dots will appear wherever the board is. I need to change this to temp position. Okay, so now if I save that, temp position doesn't need a dot position. It just needs to exist. Alright, so if I pop back into Unity now, wait for that to compile, and then if I hit play, I should see the board look the same way it did before. Oh yeah, I didn't actually set up my dot prefabs. So if I go into my prefabs here, I'll grab each of my dots, indigo, orange, red, salmon, teal, and yellow, and oops, I don't want to do that. I want to go to the board, lock it. There we go. If you didn't know about that lock up there, if you're having trouble finding or getting something to stick in the inspector, if you just use the lock, then if you type or if you click on anything else, it won't bring that up. So my size is 8. I'll unlock this now and then hit play, and we'll see if this works. Cool. So it's still working the way it's supposed to. Only now, oh, good lord. Only now, when I create these dots, I have the 0, 0, that's the background tile, and I have the 0, 0, that's the actual dot. That's at position 0, 0. Okay, so one more thing I want to do. I created this two-dimensional array for my background tiles. I'm going to create another two-dimensional array. So this is going to be private. Actually, I'm going to need this to be public. So public, and I don't want this to be background tile. I'm going to make this game objects. Public array of game objects that's two-dimensional, and I'm going to call this all dots. So that's going to be all the dots in the game. Now, after I create the dot down here, I want to make sure that I'm adding the dot to this array. So I'm going to say all dots, and then in parentheses, the I and the J position is going to be dot. Oh, no, yeah, dot. There we go. One more thing I have to do, just like I had to initialize the background tile array, I have to initialize the all tiles array as well, or all dots array. So all dots is equal to a new game object, and it's an array width by height. Okay, cool. We haven't added any new functionality yet, but what we're doing right now is going to make it much easier to understand how we can make our movement happen. So, okay, I'm going to save my script, and now I want to go back to Unity, and I'm going to create a script specifically to control the dot. So in my scripts folder, this is done compiling, I'm going to right-click, create, and I want to create a C# script. I'm going to call this dot, or game piece, or gem, or whatever you want to call it. So if I open that up, I'm going to create a couple public variables first. So just like when we were looking at the paper, the first variable I want to create is the XY position of the first touch or mouse click. So I'm going to create a private vector, if I could spell correctly, that'd be good. Private vector2, we'll call this first touch position. A lot of people tend to use small variable names. I like to use nice long ones, so if I come back to the code later, I won't forget, and it doesn't really change your memory that much. Let's do private vector2 final touch position. Okay, and then what else do we have to have here? We need to have a swipe direction. So we'll say, or actually, we'll call it swipe angle. So I'm going to use this public just so I can debug it. Public int swipe angle equals 0. Oop, except that shouldn't be an int, it should be a float, because we're dealing with the measure of an angle. Okay, so now Unity has a built-in function where it will detect if you are clicking on something that has a collider. Right now, in our scene, our dot prefabs, if I look at them, none of them have a collider on them. So what I'm going to do is I'm going to go and highlight all of these at once, rather than having to do it one at a time. And I'm going to add component. Let's go down to physics 2D, and we'll add a circle collider 2D. And by default, that circle collider will automatically be the right size, because Unity does this kind of guess and check thing where it thinks you know, or it thinks it knows how big you want the circle collider to be. So like if I click on this teal dot, if I zoom in, you can see the circle collider is exactly the right size. All right, so back to Visual Studio. So in order to call that, I'm going to call a void on mouse down. And by default, this is the left mouse click. When we have the on mouse down, I want to record the first touch position. So first touch position is equal to, now we could just take the input dot mouse position, but there's a problem with this. So if I add just a little quick debug statement here, debug.log, first touch position. Okay, so if I go back into Unity here to test this out, I just kind of want to explain what the problem is. So it's compiling down there. If I hit play, now I should only get that debug statement if I'm clicking on one of the colliders. As you can see, I'm clicking up here. But if I click on this collider right here, oh, I didn't actually add the dot script to the dots. Good Lord, I'm all over the place. Okay, so I'm taking all of these dots. I'm going to lock it, go to my scripts folder, and I'm going to add the dot component to it. Come on. All right. The other way that you can do it is if you go to add component, you can choose scripts and dot. There we go. All right. So if I hit play, you'll notice that if I click around that, not on the dots, I don't get any debug messages down here. But if I click on one of the dots, I get a debug message, which is where that mouse position is. Now it tells me it's 79.9, 210.6, which is incorrect. This dot right here is really at the position 4 and then like 14 or however high it is. The unity units is different than this coordinate that you'll be given. And the reason why is by default, Unity tracks the mouse's position using what are called pixel coordinates. So this is like 79.9 pixels over, 210.6 pixels up. So we have to go back to our script and wrap this input.mouse position function inside of another function that changes it from screen coordinates to world coordinates. So to do that, camera.main.screen to world point, and then I'm just going to put the input.mouse position inside parentheses at the end of it. And now I can get rid of this debug statement. I'm just going to comment it out because it's going to actually convert that to world coordinates. So when they click on a thing, they're going to say that the first touch position is wherever they're touching right then. It's really loud, sorry. Then we're going to have them have the system check to see if there's on mouse up. Now on mouse up isn't whether or not your mouse is up on that collider, it's whether your mouse is up globally. So what we'll do here is say not first but final touch position is equal to, and I'm going to copy this because I just don't want to type all that out. So I'll paste this down here, and there we go. So now we've got our first position and our final position. Now we need to do some math in between those two. So I'm going to create a new function down here. My function is going to be, let's say, void calculate angle. All right. So what I want to do here is I want to take the first touch position, or sorry, the final touch position, subtract the first touch position, their x and y coordinates, and I can do that kind of all in one nice thing, and then find the arctangent of y over x. So I'm going to take my angle here. So I'm going to say swipe angle is equal to mathf.atan, and there's two arctangent functions. We want to do the y over x. The reason we want to do this, pardon me, is because this way we can take our y minus y over x minus x. So we'll do final touch position dot y minus first, if I could, there you go, first touch position dot y, and final touch position dot x minus first touch position dot x. All right, now there's a few problems. Those of you guys who remember trigonometry probably remember that if you're looking for straight 90 degrees or negative 90 degrees, then the tangent function returns an undefined value. Unity already accounts for that. Now, what I want to do here is add a debug.log so that we can talk about what this does. And swipe angle. Okay, so if I save my script, pop back into Unity, and it'll compile for a second. And I'll unlock my dots from the inspector over here. Oops, did I just lock them? I did. There we go. They're unlocked now. Okay, so if I hit play, I'm going to grab this dot, pull up, and let go of my mouse. Oop. Oh, I didn't actually call the function. Good Lord. So in my on mouse up, I need to call the calculate angle function. All right, so back into Unity. It's going to compile for a second. And if I hit play now, if I click on one of these, oop, there we go. So here's the thing. This might look really unfamiliar to you if you have never dealt with radians before. So if I'm pulling down, I get this, like that's definitely not -1 degrees. The arctangent function returns a value in radians. So again, remembering your trigonometry, if I want to change this to degrees, I have to multiply it by 180 divided by pi. And to access pi, it's mathf dot capital M mathf dot pi. So now if I save this again, pop back into Unity, I'll let that compile for a second. Okay, I'll hit play. And there we go. So swipe up, 77 degrees. Swipe right, -3 degrees. Swipe down, -85 degrees. Swipe left, +175. So it's reading our angles. So it knows which direction we're swiping whenever we swipe on one of these, which is kind of the core concept to what we have to do next, which is make it find the next dot and then swap places with that dot. So we'll be covering that in just a little bit here. So give yourself a pat on the back if you followed along and everything's working like it should be. Thank you for watching, and I will continue this very shortly.